Hello and welcome to a video walkthrough for our Assignment 3 Asteroids video game. You can see that at the start of level 1 there's 4 large asteroids that appear and our ship is at the center. When we shoot the large asteroid, it is destroyed and spawns into 2 medium asteroids. When you shoot the medium asteroid, you can see it spawns into 2 small asteroids. The medium asteroids move faster than the large asteroids, and the large asteroids move faster and the small asteroids move faster than the medium asteroids. On level 2, extra asteroids appear. You can see that there's 6 large asteroids, and you can see the alien starts to visit on level 2, and he fires laser bolts at you. When you destroy an alien or a asteroid, an explosion animation plays. Likewise, when our ship gets destroyed, such as being struck by that asteroid, an explosion animation plays for the ship. And you can also see that the ship waits until the center of the screen is free of asteroids before it spawns again. You can also see that the ship has thrusters. So I just changed the velocity of the ship by using my thrusters, and it has realistic physics for the motion of the ship across the screen. One final feature that I want to demonstrate is the teleport. So when you press the enter key, the ship teleports to a random location on screen, which can get you out of trouble, but it can be quite dangerous if it places you into the path of an oncoming asteroid. Thank you for watching.
Hi, this is Chris Davidson, and this is a demonstration of the object-oriented version of our program. As you can see, the ship's flying around and shooting asteroids. I thought I'd also mention that the current resolution is a little bit smaller for this recording. I did have to scale it down for this video, but I'll scale it back up before I submit. And as you can see, I am very bad at this game. So that's our new level frame that comes up when you beat the level. And I'm not quite sure if you can hear this, but I have implemented it so you do have to like thump this fire button. Oh. And there's our alien who's going to fire at us. And that there was our wait screen and our ready frame, which pretty much illustrates everything I implemented. Anyway, thank you for watching. So yeah.
We wrote some documentation for our video game that describes game attributes such as the design philosophy, the user interface, the keyboard controls, ship movement, exhaust and lives, alien visits, the scoring mechanism, teleporting, explosions, spawning of asteroids, and the level up and game over behavior. It also describes game parameters. An example is the laser speed that determines the velocity of the laser bolt moving across the display. All of these parameters can be changed by setting the value of the appropriate variable in the processing source code. We also described all of the functions that are in the game, such as there's 48 functions in total in groupings such as initialize, draw, move, collision. An example function is in collision which is the collision detection grouping, you can see that there's a function detect ship collision alien, which detects collision between the ship and an alien. Another example of a function is the accelerate ship function, which is accelerates or decelerates the velocity of the ship when the upwards or downwards arrow is pressed. Thank you for listening.
Hi, my name's Christopher Davidson from Group 28, and this is my contribution to the Asteroids assignment for COSC 101. My main job was to convert the procedural code into an object-oriented paradigm. This allows the code to be more organized and readable, and allow for easier debugging, and meant we could implement features step by step without worrying about causing errors in earlier versions of the program. I started with a template of objects and determined which data was relevant to each object. I then started to code what each object would do in their methods. Some of these methods were directly modeled from the procedural code, which Matt and Marcus helped me understand, and once I got the main mechanics of the game working, I fine-tuned the graphics to replicate the Atari 2600 version and started to implement further features of the game, such as the end frame, which displays when the game is over, the wait frame, which includes a clear center method of the game object, such as here, and the ready frame, which pauses the game until a user input. I'm going to just stop there.
Hi, this is Marcus Gerard from Group 28. The data structures will be used were p-vectors for the main mechanics of the game, as well as multiple variables to control the game state and game parameters. Methods we used were a wide variety of functions, such as the draw, move, collision, and lives, as well as key functions for fluid movement. For the implementation, the procedural was based on the childhood memories of playing Asteroids of the Atari 2600, and the object-oriented version was based upon the example posted to Moodle. We chose values for the game parameters that would make the game both fun and make it more difficult as you proceed through the game. Matt designed the procedural and implementation of the video game, as well as writing the procedural implementation. He tested and debugged the implementation, wrote the documentation, created the Git repository, facilitated the overall project, and created components of the overview video. Chris designed and implemented the object-oriented version of the game, tested and debugged his version of the game, created the Slack channel so we could all communicate, as well as created components of the overview video. I wrote the level, lives counter, and ship lives implementation, extensively tested all implementations, facilitated the design of the gameplay, led the design decisions to replicate the Atari 2600 version of the game, designed and assigned tasks to team members, as well as created the activity diagram. There were several challenges we faced throughout the project, such as teamwork. We had problems communicating and task scheduling. Each of us had competing priorities, including heavy uni workloads, work commitments, and family commitments. As the program became larger and more complex, it became increasingly difficult to ensure the software was running robustly. The program became much larger, and it was more difficult to find variables and function references. The program became more complex, and it became more difficult to find and identify errors. We overcame some of these challenges by using several methods. We used a variety of communication methods, such as emails, Slack channels, Git repositories, as well as having regular meetings between us as a team. We had a team leader to design the implementation, as well as assign tasks to team members. We improved our commenting and documentation, as well as revised design and naming variables of the functions. Frequent iterations of programming, testing, and discussion, as well as rewriting the program in an object-oriented framework to better facilitate the expanding scope of the project. Thank you for your time.